The slinky did some pretty interesting things in zero gravity, but nothing totally unexpected. I think we were pretty sure that it is gravity that helps a slinky to slink. If you've ever played with a slinky, you know it will go down the steps, but it uses gravity as it does that. As you can see here on the ground, if you release the slinky, it flips over and it actually steps down the steps. It uses its spring forces to actually flip over, but then it counts on gravity to pull it back down to the next step. Of course, in zero gravity, you cannot make the slinky walk downstairs because there is no gravity, but it does still retain its spring forces, so that when you actually pull the slinky down like this, if there's no gravity on this end, it still has some spring forces that actually will pull it back this direction because it does have its spring force in the absence of gravity. This sort of thing, when I use my hands to simulate gravity, I'm pulling down on this end, pulling down on this end. I can do that in zero gravity simply because, once again, I'm counting on my hands pulling rather than gravity tugging on one end or the other of the slinky. Another thing that we postulated would happen in zero gravity that in fact did, if you stretch the slinky out, you're tugging on it and it has its elastic and spring properties, that if you release both ends, the spring forces will tend to pull the ends in together. But of course there is some force when the thing comes back together that will tend to make it turn around there as it floats in space. We did some wave forces in zero gravity and found that indeed the waves act pretty much the same way. They're reflected from end to end. You can make standing waves, you can make compression waves back and forth. The one thing that it does here on the ground that it didn't do in zero gravity is sag like this. Here on the ground you can't make it form a completely straight line because gravity acts on the central portion of it that's not being held. In zero gravity, of course, we could stretch it out to a great length and still have it form a completely straight line, so that we could demonstrate the standing waves and the compression waves in a much easier way.
But basically, every system like this, a spring system, it's like an oscillator. It has a certain fundamental frequency, which you can see 1, 2, 3, 4. And if I put in energy at just the right frequency, I can get it to go in that fundamental frequency. If I make it a little bit longer, that you notice it's now a little bit slower because I've made it a little bit longer. Now, if I go at exactly twice that frequency, 1, 2, now I'm going to go twice, 1, 2, 1, 2. In space, since you didn't have the sag caused by gravity, you can have a real long slinky held out all the way, and you could get very nice wave patterns going. And the wave patterns that we saw in space were really much better than what you can do on the ground. Pushing the slinky in and out with the speed being determined by the springiness of the slinky was almost like working a yo-yo, and the slinky really operated like a yo-yo. Here, obviously on the Earth, I can only do it up and down. Now, speaking of yo-yos, we did find out that certain toys in space were incompatible, and if you have a slinky going out in one direction in the cabin and a yo-yo coming in another direction, you've got to be very careful, because of course if the yo-yo gets caught in the slinky, you'll get all sorts of catastrophic results.